Have you ever wondered how much of the universe we can truly see? Everything familiar, stars, planets, galaxies, even ourselves, is made of ordinary matter. The kind that emits light, reflects it, and can be detected with telescopes. Yet this visible matter makes up only a small fraction of what actually exists. The rest is something far stranger. Dark matter. Not dark because it hides in shadows, but because it does not interact with light at all. It cannot be seen, photographed, or directly touched. And yet, without it, the universe would fall apart. Astronomers first began to suspect its existence nearly a century ago. When they studied how galaxies rotate, something didn't make sense. Stars at the outer edges of galaxies were moving far too fast. According to the laws of gravity, galaxies should have torn themselves apart long ago. But they didn't. Something invisible was holding them together. That unseen mass became known as dark matter. As telescopes improved, the evidence grew stronger. Galaxy clusters behaved as if they contained far more mass than what could be observed. Light from distant galaxies bent in strange ways as it passed through empty space, revealing hidden gravitational forces at work. This bending of light, known as gravitational lensing, showed that vast amounts of mass were present where no visible matter existed. Again and again, the same conclusion appeared. Most of the universe's mass is invisible. Today, scientists estimate that dark matter makes up about 85% of all matter in the universe. Ordinary matter, everything we can see, accounts for only the remaining fraction. Without dark matter, galaxies would not form. Stars would not gather. The cosmic web that connects galaxy clusters across billions of light years would never exist. Dark matter is the scaffolding of the cosmos. Scientists first began to suspect the existence of dark matter more than 80 years ago. In the 1930s, Swiss-American astronomer Fritz Zwicky studied the motion of galaxies inside the Coma cluster and noticed something deeply puzzling. The galaxies were moving so fast that, according to the visible matter alone, the cluster should have flown apart long ago. Yet it hadn't. Zwicky concluded that a vast amount of unseen matter must be present, providing the additional gravity needed to hold the cluster together. Decades later, in the 1970s, the mystery resurfaced on a smaller scale. American astronomer Vera, Rubin, carefully measured the rotation of individual spiral galaxies. She discovered that stars near the outer edges were moving just as fast as those closer to the center. According to known physics, these stars should have escaped into space. But they didn't. Once again, the only explanation was the presence of far more matter than we can see, surrounding galaxies like an invisible halo and keeping their stars in orbit. Since these groundbreaking discoveries, scientists have been working to assemble the pieces of the dark matter puzzle, guided by subtle gravitational clues, but still searching for the true nature of this mysterious substance. So what is it made of? That is the great mystery. Dark matter is not made of atoms. It does not emit heat, light, or radiation. It passes through normal matter almost effortlessly. In fact, trillions of dark matter particles are likely passing through your body every second, without you ever noticing. Scientists have proposed several candidates. One possibility is a type of particle known as a WIMP, or weakly interacting massive particle. Another candidate is the axion, an incredibly light and elusive particle predicted by advanced physics theories. There are even more exotic ideas, including hidden dimensions or entirely new forms of matter. But so far, none have been confirmed. To search for answers, scientists have built enormous experiments deep underground. These laboratories are shielded from cosmic radiation and background noise, allowing detectors to wait in silence for the faintest interaction. Some experiments involve giant tanks of ultra-pure liquid, watched by sensitive sensors. Others use crystals cooled to near absolute zero. All are designed to capture a signal that may occur only once in years, or not at all. So far, dark matter remains silent, but its gravitational fingerprint is everywhere. Imagine the universe without dark matter. Galaxies would never have formed the way they did. Matter would have spread out too evenly after the Big Bang. Stars might still exist, but isolated, scattered, and rare. There would be no grand spiral galaxies, no massive galaxy clusters, no long cosmic filaments stretching across space, and possibly no life. Dark matter shaped the universe long before the first stars ignited. It guided matter into dense regions, creating the conditions needed for galaxies, solar systems, and eventually planets like Earth. What makes dark matter so profound is not just what it is, but what it represents. It reminds us that reality is deeper than perception, that the universe is governed by forces and structures we cannot directly observe. That knowledge often begins with noticing what doesn't fit. We are still at the beginning of this story. Future telescopes, experiments, and theories may finally reveal what dark matter truly is, or they may show us that our understanding of gravity itself needs to change. Either way, the mystery remains one of the greatest in modern science.